Rain stations have different ways of recording their data. How do we draw the hyetograph from the provided information? Learn another approach here in hydrology. A hyetograph is a plot of rainfall intensity versus time drawn in a bar chart. The hyetograph is significant in developing design storms in order to predict extreme floods. Time in hours is placed in the abscissa, and rainfall intensity in millimeter per hour is at the ordinate. Bars are plotted at different time intervals. The second example in the series provides data tagged as time and gauged rainfall. We are to draw a hyetograph and also determine the total rainfall received. Before extending the table, let's analyze the given data. Time is in minutes, but intensity is measured in millimeters per hour. This calls for the conversion of time. 0 minutes is 0 hours. 15 minutes is a quarter of an hour, which makes 30 minutes half an hour. 45 minutes is 0.75 hour, and 60 minutes is equal to 1 hour. Also, 75 minutes is 1 and a quarter hours, and then 90 minutes is 1 and half an hour. Moving on to the gauge rainfall. Notice that the figures are increasing from 0 to 38 mm. This shows that the recorded gauge rainfall is the accumulated rainfall and not the rainfall in intervals. The interpretation of the data leads us to which columns to have in the extended table. This time, add column for the rainfall interval because it is the parameter used in computing for the intensity. Delta is then computed as the difference of the rainfall in intervals. It starts with 0 for T0, when the rain started, followed by 24 minus 0, giving 24. Then 30 minus 24 is 6. 35 less 30 is 5. And also 37 minus 35 is 2. Then 38 less 37 is 1. And 38 minus 38 is 0. Next is to take the time interval, delta as observed from the time recorded. The rainfall readings were taken at a regular 15-minute interval, which makes delta T as 0.25 hours. Completing delta D and delta T, we can compute for the intensity by taking the ratio. 0 divided by 0.25 is 0. 24 upon 0.25 is 96. 6 divided by 0.25 is 24. And 5 over 0.25 is 20. Then 2 divided by 0.25 is 8. And 1 divided by 0.25 is 4. Then lastly, 0 over 0.25 is 0. We are now set to draw the hyetograph. To draw the hyetograph, we needed time and intensity. So from the data, time 0 to 0.25, the intensity is 96 millimeters per hour. Between time 0.25 to 0.50, intensity is 24. From 0.50 to 0.75, the intensity is 20. From time of 0.75 to T1 hour, the intensity is 8. Then from time 1 to 1.25, the intensity is 4. And from 1.25 to 1.5, the intensity is 0. This is the hyetograph. Next is to compute for the accumulated rainfall, or the total rainfall volume. This is through the area of each bar, where A1 is 0.25 by 96, giving 24 mm. Area 2 is 0.25 hour by 24 millimeters per hour, which is 6 mm. A3 is 0.25 by 20, making 5 mm. A4 is 0.25 by 8, giving 2 mm. Then the last area is 0.25 by 4 mm per hour, which is 1 millimeter. Take the total of the areas and have 38 millimeters. This is the volume of rainfall accumulated. If you analyze the areas of each interval, the amounts are actually delta D, which means that to solve for the total volume or rainfall received, one doesn't need to draw the hyetograph but can compute it using the table. This is illustrated in the next video.